She does.
So today we're going to talk about function notation, and all it is, if you'll jump down to the box kind of here in the middle, we're replacing the y that we usually have with an f of x. So a function of x. All it is a notation change. Nothing else changes. Let's go up and do letter A. You'll notice that our functions in A, B, and C are f of x, g of x, and h of x, which are completely normal in the math world to use for this function notation. We simply replace the x in the equation or in the function with whatever number is inside the parentheses. And then we just crunch the numbers. So pause the movie here and do B and C, and we'll check answers in just a second. Okay, welcome back. I have these answers for G. Anybody disagree? Okay, and then for C I have 8 and I have 1/4. Anybody disagree with those?
Can you use decimals?
Okay? No, you can use a fraction. It won't hurt you, I promise.
But the decimals don't hurt us.
Yeah, really?
The whole world is decimals, and I'm going to force you to use fractions. So you're your friends. I know. God forbid we should communicate with the world. It doesn't say you have to leave them in decimal or fraction, so yes, you can use a decimal. Totally. All right, there are 3 different ways that we can talk about functions. We can see them in terms of an equation, like we saw up here in number 1. We can see them in terms of graphs, kind of like what you saw last night when you did your homework, and then in tables. So let's jump down here to our table of values. We're going to boil water to 212 degrees Fahrenheit, and then we're going to leave it alone in a room that is 65 degrees Fahrenheit. Obviously, the water is going to start to cool. Here are the temperatures taken each hour. So we have a function of the temperature in terms of the hours that the water has been sitting. So, using our table of values, can you tell me what the function at 2 hours is equal to? What's its output? Go ahead, just shout it right out. 104. And at 6 hours? 68. All right, good. So we can read that table. Letter B. For what value of H, in other words, what hour is it where the temperature equals 76 degrees? So that's an H equals 4. Okay, that's 4 hours later. And then what do you think is going to be true? How many hours, or between what 2 hours, will the temperature be 100 degrees? 2 and 3, yeah? So H is going to be between, actually it won't be inclusive, will it? Because we know what it is right at 2 and we know what it is right at 3, and that's not 100. Okay, so H is going to be between 2 and 3 hours. So far so good?
Sure.
Okay, let's go to the back. Here is an example of a function looking at the graph. So we're going to read this function and find out what the output or the y value, the range would be. So the function at -1. So we want to know where the value is when x is -1. What is our answer? What is our our y value when x is -1? 0. Yep, that's it. How about the function when x equals 1? When x equals 1, the function is up there. 4, correct. How about the function when x equals 5? Yes, Bruce, -4. So we can get answers or output from an equation like we saw in the front, from the table of values like we saw in the front, or from a graph like we're experiencing here. Letter B. Evaluate f at 0 f at 0 is equal to 3? What special feature on the graph does f of 0 correspond to? In other words, what's another name for f of 0? From, say it again, Alex?
Y-intercept.
Y-intercept, correct, from your algebra days. Nice. All right, for what I'm sorry, I'm on letter C. For what values of x solve the equation where the function is equal to 0? Stop right there for a second. Where is the function equal to 0? Its output is equal to 0. What's another name for where the function is equal to 0?
Root.
Good, it's a root. An x-intercept.
Solution.
A solution, nice. And they're all happening here on the x-axis. So how many places is this function equal to 0? 3. At 0, sorry, I lied, negative 1, 0. Is it 3, 0?
Yeah.
And 7, 0? Good. Letter D. Between what two consecutive integers does the largest solution to f of x equal 3 lie? Hold on. Between what two consecutive integers? Stop right there. Consecutive integers. Does that any clarification on that vocabulary? Consecutive means they're right next to each other. Good? Yep. And integers means they're whole numbers, positive or negative. Somebody say okay.
Okay.
Thank you. So where's the largest solution? So we're looking for the biggest number to f of x equals 3. Where does that lie? Well, the largest solution would be over here, right? Solution would be over here. Hold on, I lied. Not there. Back that up. 1, 2, 3. We want where f of x equals 3. So we want to know where that graph hits our swirly through one. What's the biggest place where that happens?
What's that say? Oh, FX.
F of x equals 3,
Yeah.
yeah. Right out over here is where that happens. Between what two integers is that intersection going? 7 and 8? Okay. So between 7 and 8. We know it's not equal to because it's not hitting right on the chunk of graph paper. And example number 4, please. For a function y equals g of x, it is known that g of negative 2 equals 7. Which of the following points must lie on the graph of g of x? So they want to know, do you know which is the x value from here, 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 there? What's the x value? What's the y value? What are the coordinates? Anybody know? Say it again, Caitlin. Negative 2, 7 are the coordinates. So this is the x value, and this would be our y. So choice 2. All right, so physics students are dropping a ball from a 50-foot high building. I hope someone's making sure nobody's underneath that. And they gave us the function of the height based on the time. So clearly, there's going to be a negative height happening there, right? So that subtraction sign makes a little sense. Start at 50, that's how high the building is where they're standing, and then drop it. Use your tables on your calculator to determine to the nearest tenth of a second when the ball hits the ground. And then we're going to create part of our table to show our answer. So calculators on, and put this equation in your calculator, please.
Can we put y instead of h and t?
You're just going to put in 50 minus 16x squared. Because your calculator can't do h or g's or t's or any of that other fun.
I can tell it.
Calculators are limited in some respects. Then we're going to go look at our table.
Yeah.
Oh, clearly I'm in the wrong place.
Oh.
I'm going to head something to like number 5, because that ball can't be in the air too long, right? If it's 50 feet off the ground and it's dropping. So now I'm supposed to find, oh, it's not in the air very long at all. Somewhere between 1 second and 2 seconds, the ball hits the ground.
Huh.
Pretty fast, right?
Yeah. Book 21.
So we got to dig in a little deeper. They want us to round to the nearest tenth of a foot. Do you remember how to make our calculator see the table a little differently?
Window.
Right, second window to get table set. I want to start at 1, and what do I want to count by? What is my delta table going to be?
0.1.
Yeah, because we want to round to tenths. So 0.1. All right, so now go back to our table. Can we tell where we're going to get to 0? When we're going to get to 0.
Somewhere between 1.7 and 1.8.
Yeah, somewhere between 1.7 and 1.8.
I'll say 1.75.
What are we trying to get to?
I think you don't hit your, oh, this needs to be an X squared. Now you're in good shape.
Okay, so between 1.7 and 1.8. Does it say we have to determine the nearest tenth of a second? I'm just going to get all kinds of crazy here. I know you're kind of used to that. So I'm going to start at 1.7, and I'm going to count by 0.05. I know. Exciting stuff. So between 1.75 and 1.8, it's going to hit the ground.
What'd you count by?
I counted by 0.05s.
What's the top number? The table
Yep,
square?
I'll bring it right back.
But it's closer to 1.8.
I didn't, yep. And just because I'm, that big of a geek.
Past 1.765.
Is it?
Yeah.
Alright, well you guys go ahead and have fun with that.
So 0.4 of an inch off the ground at 1.76.
Can't we just write something?
Yes, we can. We're rounding to the nearest tenth of a second. So if I'm at 1.76, what's my nearest tenth? If I'm at 1.76, 1.8 is my nearest tenth. What they want us to do is put a little bit of our table in here. So what I did, T and H of T, and I just did 1.6, 1.7, 1.8. And you're welcome to use my numbers if you've got your calculator doing all kinds of fun stuff.
You gotta find the answer. And tell exactly when it hits.
Okay.
I still have to find
Would you like me to give you the shortcut for that, or do you want to?
No, I'm about to find it.
Okay, great. Have a good
That's what
time.
you say.
Yeah, of course, that's always what to say, isn't it?
All right, so not anything really scary for today's notes, okay? Using equations, table, graph, and then just getting kind of familiar and comfortable with this idea of the function notation, how to read it and how to use it. So good luck with your homework.